Okay, so in this particular video, we're still talking about review, but we're cranking it up just slightly. We're talking about solving linear equations. You probably have done this before. Again, if you need to skip this video, go for it, but it never hurts to get extra review. So, an equation is a statement in which two expressions are equal. Again, we talked about what an expression was in the previous videos, so if you need to check out that definition, please go back to that video. Two equations are equivalent if they have the same solution. So that means when I get a variable by itself, it's going to solve or unlock the door for both of these equations. So for instance, I want to solve 3/7 x plus 9 equals 15. Anytime you're solving an equation, your first objective is to get whatever variable you're interested in, whether it's x, y, z, smiley face, whatever your variable is, you want to get it by itself. And we're going to do that by the reverse order of operations. So what that means is, reverse order of operations is add and subtract comes first, then multiply and divide, then we're going to take care of any exponents or powers, and then last thing we would take care of is any parentheses. Okay, so reverse order of operations. Make sure you know it. So, to solve this, we want to start getting x by itself. The very first thing we need to do is to get 9 on the right-hand side. We have positive 9. Opposite of positive is negative, so we say minus 9 both sides. Cancel out, so 3/7 x is equal to 15 minus 9. If you can do 15 minus 9 in your head, that's great. If you can't, use calculator. No big deal. But 15 minus 9 is 6. Okay? And now we want to get x by itself. We have a fraction. The best way to eliminate a fraction is always just simply multiply by whatever is on the bottom. In this particular problem, 7 is on the bottom. But as we go on through the course, what we're going to see is you don't always have a number on the bottom. Sometimes you're going to have a variable. Sometimes you'll have something else entirely called a trigonometric equation on the bottom. That's later in the course. Don't freak out. Right now, what we're going to do is multiply by 7 both sides. And it's very important that I said both sides because equation means balance. What you do on one side, you have to do on the other because you want to stay in balance. If you only do it on one side, like when you were in elementary school, your seesaw will be out of balance. So, 7 and 7 will cancel out. And we're just left with 3x on the left. 7 times 6 is 42. And then finally, we want to divide 42 by 3. So, we're going to say, because opposite multiplication is division, so we divide by 3. And I'm actually going to do this in my calculator. I could probably do it in my head if I thought about it, but I want to save a little bit of time and show you that calculator is okay, no matter what your experience level. And I get 14. So my answer, or my solution for this problem is x equals 14. Now what we did, again, I circled my final answer. It's called the algebraic solution. I actually worked it out, showed all my steps. What I'm going to show you next is actually how to do the exact same problem by graphing. If you have a graphing calculator, you can solve virtually almost any equation. If you see equals in the middle, you can solve it. That doesn't mean that this algebraic method that we did right here is bad. This is very good. You need to know how to do this. But I'm just showing you an alternative, especially if you're in a time situation like a test where every second counts. Graphing might be a better option for you. So again, I'm just going to start off with the same problem. 3/7 x plus 9 equals 15. And I'm going to graph. So when I say graph, what I mean is the left-hand side, whatever's on the left, is always going to go in y1. The right-hand side, whatever that is always going to go in y2. Now, I'm using a TI-83 Plus. This is an older calculator. You might have a newer calculator, but the strategy should be pretty much the same, but the commands on your calculator might be slightly different, especially if you're using a different brand. This is Texas Instruments. There's other brands out there. So just refer to your owner's manual, but you should be able to do pretty much the exact same thing I'm doing. So I'm going to go to y equals to graph. My left-hand side goes in y1. Now, anytime you have a fraction, you have to put that fraction in parentheses when you put it in my calculator. So if you don't, it's going to come out wrong. So I'm going to actually say every fraction gets the parentheses around it. So I have 3/7 x plus 9. I'm done with y1. Now y2, I want to hit 15. and then I'm going to graph it. Every time you do graph something, you want to hit Zoom, Option 6, Standard. That way we're all starting on the exact same picture. Now what I'm looking for is the intersection. Where do these two graphs cross? Y1 and Y2, where do they cross? Wherever they cross, that's where my answer is going to live. Well, I can't see my 2 points of intersection, so it looks like the graph is going up, 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 up. So I'm going to zoom, Option 3, zoom out. And when you zoom out, you actually have this little cursor you can move around and get it right about where you want it to be and zoom out. And now that I hit enter and told the calculator to zoom out, I can clearly see my point of intersection right here. Well, I don't want to eyeball that. My calculator can tell me exactly what that point is. So what I'm going to do now is hit second, calc. It's right where the trace button is. Now I'm going to go down to option 5 for intersection. Kind of makes sense. I've been talking about intersection this whole example. So option 5 for intersection. Now, it's going to ask you a couple questions. Just answer them. First curve, all you have to do is hit enter. The second curve, all you have to do is hit enter. But when it says guess, you actually have to move your cursor. Your cursor is this little flashing thing here, and you want to move it as close to where you think that point of intersection is as possible. Once you get it in position, then hit enter, and it tells me that my intersection is at x equals 14, y equals 15. It gives me 2 values. This particular problem is asking about x, so by graphing it, x equals 14. Circle it, done. I got the exact same answer by showing a whole lot less work. Again, as long as you get the answer, it doesn't really matter. And that's it for this video. Hopefully you like the algebraic expression and graphing. We'll practice graphing as we go on throughout the semester.